Let's talk about how to handle significant figures when it comes to addition and subtraction. So let's say you had a number like 8, 9.332, and you are adding this with 1.1. And when you perform the addition, you find that what you get is 90.432. Now, how can you write the final answer? Since these have different number of significant figures. So for addition and subtraction, how to round off the answer? You find that we are going to follow the one that had the least number of decimal places between the 2 or the 3 or the 4 numbers that you're adding. And in our case, we are just adding two numbers. So which one has the least number of decimal places? So we know what decimal places are. These are just these are just numbers that come after the decimal point. So for example, this one has 3 decimal places, while this one has 1. So say this one has 3 decimal places, 3 digits after the decimal point. Okay, but this one just has 1 decimal place. Okay, so you follow the one with the least number of decimal places. Okay. So basically we are saying your answer should cut like this. Since this one just has 1 decimal place, even your answer should just have what? 1 decimal place. So now once you know that, the next thing that you determine is whether this 4 will increase or it will remain like this. But in our case, it will just remain like this because 3 does not have the power to increase 4 to a 5. So your final answer is just going to be 90.4. That, okay. So to just solidify what I just said, let's look at another example. What if we had 2.097? Then you are subtracting 0.12. When you perform this on the calculator, you're going to get 1.977. But you try to check the one with the least number of decimal places. This one has 3 decimal places, while this one just has 2 decimal places. So your answer should also have 2 decimal places. In representation, it should cut like this, since this one has nothing here. Okay, it should cut like this. So your answer should also cut where this line is cutting like this. Okay, so does this 7 have the capacity to increase this other 7? Yes. So this one is going to change to 8. So you're going to have 1.98. So the idea is not that hard to grasp. If the least number of decimal places is 2, your answer should also have 2 decimal places. If it's 1, your answer should also have 1 decimal places, 1 decimal place. If it's none, your answer should have none as a decimal place. Okay? So that's how you go about addition and subtraction of significant figures. Now, when we look at rules of handling significant figures when it comes to multiplication and division, you find that they are different. So let's say you had 4.5039, then you are multiplying this with 2.8. And when you punch this on the calculator, the answer you're going to get is going to be 12.60192. Okay. So how do you write this in a correct format? For addition and subtraction, you take the number of significant figures, not decimal places. Here we were considering decimal places. Here we consider significant figures. This one has how many significant figures? 1, 2, 3, 4, 5. This one has 5 significant figures. This one has 1, 2, just as 2 significant figures. Okay. So your answer should have 2 significant figures. You get the idea, huh? So now, if we write that 12.6 has 3 significant figures, so it can't qualify. So it just needs to have 2. So to do that, we're going to round this number off, and we are going to get 13 because 6 has the capacity to increase what? 3. Right. So if we were considering the number of decimal places, we would say this one has 1 decimal place, and this one has 1, 2, 3, 4 decimal places. So it's different when it comes to significant figures and decimal places. Okay, the second example is let's say you had 6.85 and you were dividing it by 112.04. And if you punch this on the calculator, the answer you would get is 0.006113887 okay. So you need to round it off. Now to what? You check the number of significant figures. This one has 1, 2, 3 significant figures. This one has 1, 2, 3, 4, 5. 5 significant figures. So you take the one that has the least, and you find that this one has the least. So you take 3. So your answer should have 3 significant figures. And these are trading zeros. This one is not significant, not significant, not significant. But when you reach here, this is significant, significant, significant. So we only need 3 significant figures. This is going to be 0.00. These are not significant. This one is significant, this one, and this one. So your answer is going to be 0.006611. The final answer. In scientific notation, it would be 6.11 times 10 to the negative what? 1, 2, 3. Negative 3. Okay, so these are significant. Do we need to do another example? Okay, let me just do one on addition and one on multiplication, then we end this session. Oh, that was a rhyme. So we have 1124.1 grams. Then we are adding 0.1983 grams to this. Okay, let me just remove the grams so that the confusion tufunimpo. So let me just write it like that. So for addition and subtraction, we said that we consider decimal places. This one has 1 decimal place. This one has 1, 2, 3, 4 decimal places. Okay. So you get the one with the least. So if the least upper is 1, even your answer should have one decimal place. So when you draw that line we are drawing, we are saying everything else that is here is useless. It can only be used to either maybe increase the answer. So this is going to be, when you write it on the calculator, you're getting, remove this line so that it doesn't confuse us. So it's going to be 1,125,4.2983 grams. Okay. So now writing it, when we put back that line that we put, we are saying that if ifyashara fyonso feel useless, maybe it can just be used to increase this. You get ka? Since we are saying that the least number of decimal places is 1, and that's what we are getting. So the final answer is going to be 1,1,254.3 grams. The least had 1, even your answer should have 1. Let's quickly do one for multiplication. Say you have 2.64 times 10 to the power 3, and you're multiplying this 3.27 times 10 to the power 2. How do you go about this? Well, simple. These two will multiply, you get 2.64 times 3.27, then times 10. The exponents will add 3 plus 2, then this will give you, are we getting 8.6328 times 10 to the 5 centimeter. Oh, I didn't include centimeter, so there is no need for me to include it now. Let me just remove it like that. So now, how do we write this the correct way? How many significant figures is it supposed to have? Well, you consider the one with the least number of significant figures, and that's what your answer will also have. If the least number of significant figures is 2, your answer will also have 2. So we find that this one has 3 significant figures, then this one has 3 significant figures. So your answer should also have 3 significant figures. This is significant, significant, significant. You end here. It's going to be 8.63 times 10 to the power 5 as your final answer. So that's how you go about that. As a final note, guys, for addition and subtraction, you consider decimal places. Please keep this in mind. Kakesapa test one, and I'm sure about that. And for division and multiplication, consider the number of significant, Katuishi, this spelling is correct, significant figures, please guys, okay? And you take the one with the least number of decimal places or the least number of significant figures when it comes to division and multiplication. So take note of these guys. Right, let's end the video here. I think Twalanda san. I'm going to see you in the next one.